equations. Let's have a look. What? Great, we're already on lesson 6. Does anybody know another word for equations of motion if you've studied it before? It begins with a K. You're getting close, but not quite that. You need to make it an adjective. More of an adjective. Kinematic. Do you know this word?
No.
Yeah. I don't really use it. I just say equations of motion. So let's have a look at this now. Can you write that down, please? And we'll start this. Okay. So we kind of haven't said exactly what linear motion is, although we were sort of doing it last time. So to be precise, uniformly accelerated linear motion, what exactly is that? Well, let's look at the maths words we know. What's linear? You remember linear from maths class? What does that mean? Straight line. Yeah. And uniform? Constant. So it's constant acceleration. Is motion which is in a straight line, that's the linear part, and has a constant acceleration, that's the uniformly accelerated part. And this is a very common type of problem in physics. One of the most common types of problems. That's okay? Yeah. A couple of people still write it, and then we'll continue. Nearly have that, Bruce? Yeah. What word are you on now? Oh, good. Okay, that's good for you. So, if you were to graph this type of motion, you would just have a straight line. Just straight line. No changing like that. So, let's see what equations we can make with this type of motion. Okay, so let's start with our distance, speed, time triangle. What is distance equal to on this triangle? Yeah. So distance, I know this is displacement, but just for the moment we'll say distance is speed multiplied by time. That's fine. But the problem here is that what do we use for the speed? Because we have two speeds, u and v. So do we use u or do we use v? What do we think we could do? Not v. I mean, the average, yeah. Not u, not v, but the average. Yeah, we should use the average speed. Remember, I was saying this last time that we can still use the triangle, but we have to remember now things become averages. Yeah. Okay, this is one of our equations of motion. Okay, in fact, I usually call this equation 0 rather than equation 1, because in physics, sometimes when a rule is very basic, you don't call it like the first rule, you call it like the 0 rule. Okay, I didn't really do anything to prove this. I just used the middle school triangle and replaced speed with average speed. So it's not really special, but it is useful still. So this is like our first rule. Let's look at something more interesting. So remember we said acceleration is the change in velocity over the change in time, which is v minus u over t minus 0, which is v minus u over t. So that means a multiplied t equals v minus u, which means we have this formula. The v at the end equals the u at the start plus at, yeah. And this now is like what I would call our first equation. Okay, I'll pause for a moment to let you write this down because I have two more to prove. Loud. I'm sure some people have seen this before. Vf equals Vi plus At. Okay, continue. You know this? Right. So what I'll do next, I'll just take this and rewrite it as t equals v minus u over a, yeah. And then with that, I'll put it in here. So now I get s equals u plus v over 2 times v minus u over a. So that means I get 2as equals uv minus u squared plus v squared minus uv. They cancel, of course. So you can end up with v squared equals u squared plus 2as. This is our second equation. Yeah? Can you see okay? Yeah. Okay. For those people who've seen this before, I have one more equation to prove. Does anybody know what's the next thing I can do to prove it? Yeah. Oh yeah, no, but I want to know how to prove this. The S up here? Or the S down here? Yeah. So take this and put it in here. No. I had to think about that. I don't think it will get there. In fact, there's something a little simpler than that to do. What we can do is we take this from V and put it in here. So we get S equals U plus AT over 2 times T, which is 2U plus AT over 2 times T, which is U plus a half AT times T, which is UT plus a half AT squared. So we have S equals UT plus a half AT squared. Number 3. Yep. How far? Tell me when to stop. Okay. Okay. The people who've studied this before, have you seen the proofs before like this? Yeah? Have you seen these proofs before, Bruce or anybody?
No.
No?
My middle school teacher just showed me
The formulas. But you've seen these formulas?
Yeah.
Not the proof. Have you seen the proof or just the formula? Just the formula, yeah. This proof could be on the exam. However, I've never seen it on the exam, but in the syllabus it says it could be. There's about 3 proofs you need to learn for the exam. And of the 3, I think it's 3 proofs, and of the 3 proofs, 2 of them are very, very common, and the third one, which is this, I've never seen on the exam. So like there's 10 years of exams, there's 2 exams a year, so there's 20 exams, and I haven't seen this proof, but it could be on the exam. So this is your first exam proof, a proof you need for the exam. But will they ask it? I don't know. So far they haven't. Okay, can I continue? Yeah, these proofs are on the exam. So to summarize, we have S equals U plus V over 2, V equals U plus AT, S equals UT plus half AT squared, and V squared equals U squared plus 2AS. To solve any of these, we need to know at least 3 of the UVATS. So for example, if you know UVA, then you can get TS. You need to have at least 3. These problems are often called SUVAT problems, SUVAT, but I call them UVATS problems because that's what my teacher called them, and I haven't gotten out of the habit of calling them this. Most American physics books will call them SUVAT problems. I would call them UVATS problems. Yeah. SUVAT is a word you've seen before? No? Okay. UVATS then. Okay. I do prefer SUVAT because it's quicker to say than UVATS. They're also known as kinematics equation of motion, but just equation of motion will do. Okay, so now let's have a look at some questions. So if you can write this one down, we'll do it together. Okay, let's do this. So we have UVATS. What do we know? She starts at rest. So what does that tell us? U is 0. And she cycles up to 9 meters per second. So the 9 is B, very good. And of course, obviously, the T is 6 then. So let's write this info down. U is 0. V is 9. And T is 6. And we want first the S. So what formula to use? Let me just fix that now. Yeah, which formula should we use? Which one? S equals U plus V over 2 times T. That would do it. Yeah. S equals U plus V over 2 multiply T. So that's 27, isn't it? And next I probably want the A. What formula should I use to get the A? Yeah, the V equals 1. So V equals U plus A T. So that means 9 over 6 equals A, which is 1.5 meters per second squared. It's okay? Yeah. That's an easy one to get started. Okay. Continue. Right, here's another one. You can write it down, or you can just write the information down if you understand the English. And I'll do this now in 1 minute. So we have a car is travelling at 120 kilometers per hour on the motorway. The driver sees a crash up ahead and suddenly brakes. That brake is spelled wrong, isn't it? Yeah, he doesn't brake. According to the RSA, it takes 100 meters to bring the car to rest. So, what's the acceleration of the car while it's braking? Okay, so just write this down and I'll do it now in a minute. And if you're writing it down, there's no E in brake. It's B-R-A-K-E. There's no middle E here. You don't have to write the whole thing down. Once you have the key information, like 120 kilometers an hour, 100 meters to stop, all this stuff. Okay, ready to do this one? Yep. So, here what's the U? It's 120 kilometers per hour. And we'll need to change that. That's 120, and a kilometer is 1,000, and an hour is 3,600 seconds, so that's meters per second. So the U is whatever that is. Does somebody have that? 120,000 over 3,600. Okay, yeah. The V we know, the A we want, the T we don't know, and the S we know. And first I'm looking for the A. So, which formula is that? Yeah, the V squared one. So V squared equals U squared plus 2AS. So that means A is minus 33.33 squared over 200. Can you tell me what that is, please? Yeah. 5.56. Okay. And next at the time. So we'll go with V equals U plus A T. So T is 33.33 over 5.56. So what's that, about 6 seconds or something, is it? Yeah, it's about 6 seconds, isn't it? Can someone give me it exactly? Six seconds. Yeah. Is okay? Continue? Yes. Oh, great. Did you say you needed to use the computer for this?
Yeah.
Super, because no, it's all set up here, so I'll just switch it to this then.
Lovely. So we've got a full house, do you?
Yeah, everybody's here, aren't they?
There isn't a call out here, is there? No.
Not yet.
No, okay. So we actually came in the first day.
Quite interesting. Okay.
So the start of it.
I'll get a cup of coffee then, so give me a couple of minutes.
Yeah, about 5 minutes.
Yeah. Don't get too angry at them now, they're nice students. I'll see some of you in a few minutes, but not all of you.
Thanks, David. So guys, I'm just here to talk to you very briefly about the IST attendance policy. Okay, it's really important that you attend all of your classes, and I will explain to you why, and then I'm going to explain to you what will happen if you start missing classes. Right? So, first of all, you must attend all of your classes for 2 big reasons. The first one is academic. Our courses are very challenging, they move very fast, you probably noticed that already, and even missing one class means you can start falling behind. Okay, so every 50 minutes that you miss with Stephen is another 50 minutes that you have to catch up on, and that can get really difficult really fast. So the first reason is academic, second reason is legal, the law. Okay, you have a legal obligation to attend your classes. The Irish government gave you your visa to be a student, you've got to be in your classes. That's part of the promise. Okay? And the government is watching the schools with international students very closely to make sure that we are making our students attend, that we are strict with you about this. Okay? So it's not just us saying this, it's the government saying it to us. Alright? So academic, legal. These are both the reasons why you have to attend all your classes. So what happens if you stop attending classes? I will tell you now. There's a 4-step process. So step 1, if we notice when we do our weekly check and all the numbers, if we see that your number is gone below 90%, then you will be brought in for a meeting with Emer, okay, in the Student Affairs office, okay, with Student Services. She'll bring you in for a meeting, ask you what's going on, and give you a verbal warning. So a verbal warning meaning it's not written down, it's just she's telling you, you don't get a letter. After that, you must have full attendance, you must have perfect attendance until your percentage is back over 90. And then it has to stay over 90. Okay? Now, after 1 week, Emer will check your weekly attendance. If you haven't had perfect attendance, you've missed a class for any reason, she's going to bring you back in for another meeting, and this time you do get a letter. Right, you're going to get your first warning letter. Again, you have to have perfect attendance until your percentage is back up over 90. Now, after that week, it's not Emer who checks the percentage, it's me. And this is where you're getting into trouble, okay? You then are called for a meeting into my office, and you're going to get your final warning letter. And again, the rule is clear: perfect attendance until you're back over 90. So you're getting lots of chances to improve, okay? We don't just chuck you out. We give you lots of chances and we give you lots of warnings, but this is your last warning. And I will tell you in this meeting, you have 1 more week. I will check you. Well, actually, it's not 1 more week. You have to have as many weeks as you need to get back over 90. And if that happens, you'll be called in and you'll get an expulsion letter. And expulsion is the noun of expel. You're out. Okay? So this can happen in a space of 1 month. Okay, with those weeks if you don't improve. Okay? But I think you'll agree it's pretty fair. We give you verbal warning, first warning letter, final warning letter before you are expelled. Okay, so you have lots of chances, and it's really easy. You just have to have perfect. You just have to be in class. That's all we ask. Okay, but as I say, we have to be strict on this because the government is watching us. So just a couple of frequently asked questions. Okay, about attendance. So first question: what do I do if I'm absent? Okay, because life happens. You're going to maybe be sick, or you have to go to GNIB, or whatever. Maybe your microwave exploded in your apartment, whatever. So what do? You email us. Okay, send an email to this address. Now I'm going to be emailing everybody with this policy. It's going to be on Moodle, so you'll have this address. absences@CIST.ie. So it's a special email where we take all of the absences in. Now you explain, you say, hi, I'm absent today because I have a GNIB appointment. So you send it to this address, but you should also copy in your tutor. So your tutor is Isabel, exactly. So just copy Isabel so she can see that you've done it. And also, whichever teacher is going to be missing, so that they're not worried about you. So, for example, if you're going to miss this class, you just put Stephen in as well. Just copy Stephen in. Okay. Don't write separate. Don't write 3 emails. It's wasting your time. Write 1 email. Put everybody on the same email, and then Stephen won't be worried. At 9:30 when you're missing, he won't be asking me or asking Sylvia or whatever. So send in an email, and you should do it as quickly as possible. If you wake up at 8 o'clock in the morning and you feel very, very sick, you're not going to be in school today. Send the email at 8 o'clock. Send it in bed. Okay, let us know in advance. Then we're not worried about you. We're not chasing you. Okay, so send it as soon as you know you'll be absent. All right. So that's what you do. Now, will my attendance drop? So will my percentage drop if I'm absent due to illness? Does anyone know the answer? Yes. Unless you submit a medical certificate. Okay? So if you go to the doctor, you ask the doctor for a medical certificate, and he will say, Jerry was unable to attend class from this date to this date, and in this case, we don't cancel classes. So for example, if Jerry has perfect attendance of 100%, and he misses 5 days of classes, but he has a medical certificate, he still has 100%. Okay? If you don't have a medical certificate, we can do nothing. We need to have evidence. Okay? What if I'm only sick for 1 day, and I don't bother going to the doctor for a medical certificate? Will my attendance drop? Yeah, because you don't have a medical certificate. Yeah. Now you should still email us at absences@CIST.ie to let us know, and we put a little note in your file. Okay. Now this is important because, let's say for example you have a situation that keeps coming back. Let's say for example if you have a stomach problem that means you're very sick 1 day every month. if we put that into your file and your percentages dropped but you haven't gone to get a medical certificate, we will see, okay, this student, they were in contact, it's the same problem that keeps coming back, we can write a little, we can put something into the letter for G&IB if we have to support you, if you let us know, okay? Now if you want to keep perfect attendance, yes, go and get a medical certificate. However, if you're generally a good attender, if you're like 100%, one day of illness isn't going to be the end of the world, okay? So, don't go rushing to the doctor if you're going to miss 2 classes because of a stomach problem, okay? But still email us and we'll put it in the file. Will I be marked absent if I'm late for class? What do you think? Yes, but importantly, how late is at the discretion of the teacher. Because the individual teacher has their own rules, you must follow those rules. Many teachers allow the 15-minute rule, so if you're in the classroom before 15 minutes, then you're in. If you arrive after 15 minutes, you lose the first class. Okay, so generally a 15 minutes for a double class. Some teachers have different rules. If it's a 1-period class, so it's only 1 hour, then 5 minutes is the deadline. Some teachers will say, I don't allow any lateness, you must be sitting in my class at 9 o'clock or you're marked absent. Okay? You cannot argue with the teacher on their policy. Okay? The teacher marks you out, you're out. Don't make a fuss about it, just learn your lesson. Okay? So you need to know what the individual teacher's rules are on lateness. Most teachers go for the 15-minute rule, but some are stricter, know the rule and stick to it. Okay? What's your policy for 15 minutes?
I don't know what's been late yet, so it hasn't come up, which is good. But usually, 15 minutes, I actually don't let the student into the class.
There you go.
Because it's too disruptive. So if you're 15 minutes late, I just tell you, come back for the next class.
So that means you're absent.
Yeah, definitely.
Yeah. So what's your kind of cut-off? Or are you a...
15 minutes, but if you're doing it more than once, then it will start to become a problem, and maybe I'll have to tighten up a bit.
Yeah, and again, this is all at the teacher's discretion. Let's say Jerry, is coming consistently 14 minutes late.
That's if you
Stephen
want to make me angry, that's a very good way to do it.
Yeah, but then Stephen has the right, as your teacher, to say, Jerry, you have to be sitting in my class, no exceptions, at 9 o'clock. Okay, and Jerry then has his own personal punctuality plan. Okay, sorry, Jerry, we're picking on Jerry a lot, sorry. So I was using his as an example as well there earlier on. Okay, so is that clear? Yeah? Okay, what if I get a verbal warning? So verbal warning is step 1. And imagine that you then have full attendance to get back over 90, and you stay over 90 for 1 month, or even 3 months or 4 months, but then you fall back down again. Do you go back to the start of the process, or are you on to the next warning? Okay, so what I'm saying here is, does the verbal warning stay on your file forever, or does it disappear after a few months? Well, the answer, do you go back to the start of the process? The answer is no. Okay, the verbal warning stays on your file. So if you get a verbal warning this month, and then you get back up over 90 and you stay there for 6 months, that verbal warning is still there. So if you start poor attending again, you're onto your first warning letter. Okay, do you understand what I mean by that? The verbal warning is permanent. It doesn't disappear. Okay, so we'll be watching you. Okay, what about serious personal circumstances which result in absence? Surely my attendance won't drop then. Because life does, other things in life happen that could cause absence, serious situations. Will your attendance drop? I'm afraid so. Okay? Personal medical certificates are the only documents which allow us to alter your percentage, which means we don't count those classes. It's like they're not on your record. However, in serious situations like illness of a family member or a death in your family that could result in a longer absence, we can help you. So what do you do in the case of an emergency situation like this that could mean a long absence? Let's say you have to go home for a week for a funeral, something like that. The first thing you do, you must talk to your course leader, you must talk to Connell. You don't just disappear. If we get an email from you to say, I'm actually already at home, this is trouble for you, okay? Because you have to follow our procedures. If you want us to help you, you have to follow our rules, okay? So talk to your course leader first, who will make a plan with you. Secondly, get any documentation that's evidence of your situation. So if your granny is sick in hospital, you get a medical certificate from her doctor. If somebody has died, you get a copy of the death certificate. I know that sounds kind of grim, but you need to have evidence. Now, if you get that evidence, what will happen is when you go to immigration with your letter, and the percentage is bad, like 65%, if you have that evidence, we will also write a letter explaining your situation, and the person in immigration will bring your percentage back up. Okay, we can't do it on our spreadsheet, but they will understand the situation. So it's not a disaster, okay, if you see a low percentage. If you have those documents, we can help you. What's the other really important reason for keeping documents like this? I mentioned this last week. Does anyone remember? Why do you need to talk to us and keep documents? Does anyone remember? Okay. At the end of the year with your final exams, if you are borderline, maybe you are 59.5% and you need 60. If you have this documentation, if you have this certificate, we can fight for you in Manchester at the final meeting with the grades to get you to 60. Okay, if you give us this evidence. We can say, okay, the student has 59.5, but they had a very bad situation. We believe the student is a B student. Can you push the grade up? Okay. So the two reasons. It's for, again, academic and legal to keep this documentation. Okay, what if I think my attendance rate is wrong? So you go into Sylvia, ask, what can you tell me my attendance rate? She tells you 73%, and you go, that can't be right. So what do you do if you think your attendance rate is wrong? It's not wrong. You're wrong, okay? Your impression of your own attendance is incorrect. The computer is correct. Your idea of yourself is incorrect, okay? I'll just give you a quick example, and this is why it's so important, especially at the beginning of the course, to attend really well. Imagine you only missed 2 days in the first 3 weeks, okay? How can I be below 90%? How is that possible? Why is Emer calling me to give me a verbal warning? But if you imagine, if you have 7 classes in both of those days, you have 14 classes, right? In 3 weeks, you would have 84 classes about, okay, so 28 times 3. So you've only attended 70 out of 84, which is already down to 83%. So it can happen really quickly. When you miss 2 days of classes in the first 3 weeks, you're on 83, you're already on your first verbal warning. That's how fast it can happen, okay? So don't miss that. So your attendance rate is not wrong, but hang on a second, it's just a spreadsheet in student services. Can Sylvia just maybe delete and type in a different number onto my letter? No, and please don't ask. That's not how things operate here, okay? By going in once, twice, 3 times to ask for a different percentage, it's not going to work. It's only going to make us angry, okay? So don't ask. We can't change it. So then, what can I do to improve it? What do I do? If I want to change that number, there's only one thing you can do: attend all classes. It's the only way. Okay, is to attend your classes, and then your percentage will start to go back up. Okay? So that's our attendance policy. I'm going to be putting it up on Moodle, okay, and you'll be getting an email with it attached as well. And we're going to keep reminding you of this, because it's really important that this sinks in. Alright, attendance is so important. Does anyone have any questions?
Maybe just to finish on positive, I know it seems like we have a lot of rules, but really it's for your own good from our experience working with immigration and universities. So, they are for your good, not just to make us happy because we like having lots of rules.
That is true. I mean, this process, it's meant to be to help you to stop the problem getting really serious. Okay, so we warn you early so that you don't get into a really serious situation with immigration. It is there to stop a very big problem by making it difficult for you at the very beginning. Okay. God, did I come across a bit?
Thank you.
But in fairness, now nobody's been late yet, so I think the engineers are probably the best group of students. Wouldn't you agree?
Oh, well, listen, I mean, the thing about past groups of engineers, definitely.
Yes. Good so far. What time is that? This little thing that's
At 11:30.
that's 11:30.
Yeah.
And then 1 o'clock is for the
Yeah.
staff thing.
Yeah.
Okay.
Right,
Great.
we're all a little bit busy.
Yeah. That's okay. That's okay. Graham, thanks for that. Okay, guys, we'll continue then. Right, what were we? Yeah, we were finishing this example, so I think we were going to go on to the next slide, wasn't it? Yeah. Okay, so now that we're getting the idea of how to do these, I'll do this one again, but I think this time you should be able to try this. Yeah, so I want you to try it and see what you get. Oh no, you don't know that yet, so you can't use that. Yeah, and it's not 10. Yeah. Not that either. We use a different one. Okay, we got this one finished yet, or finished? You got both parts? Uh, 1 minute. I see a couple of people writing, and then I'll do it. Okay, I think that's enough time, I hope. Let's have a look at it. UVATS. And in the story, you have a building. How tall is the building, did I say? 25 meters. And how long did it take for it to hit the ground? I probably told you this, didn't I? 2.26 seconds. Okay. So what's the U?
0. The v we don't know, the a we don't know, the t 2.26, and the s kinda. I would prefer if you said the s was minus 25. Why? It's going down, yeah. Now if you actually said 25, that's fine. It just means your answer for A was probably positive, which is okay. But I prefer if you would think about it as a minus, because the ball is lower than where it started rather than higher. Because in this picture here, if the ball went up in the air, I would like that to be a positive, and it fell down to the ground, I'd like that to be a negative. Okay. So, first I want the A. What formula can I use here? S equals, yeah. S equals ut plus a half a, great, t squared. So this looks like a will be minus 50 over 2.26 squared. What's that, 9.8? Over 2.26 squared. The 50 came from me multiplying 25 by 2. Can someone tell me this, please? Bruce, maybe, since you have a calculator and you know how to use it? Thank you, Bruce. You're so kind.
Negative 9.2.
Thank you. Yes. The answer is probably no. Go on. Did you pick that up in high school? Bad habit to be thinking about it that way if your teacher taught you that way. I understand if it's going up, it's acting against, it's negative, and it's going down, it's assistant, so it's positive. That's okay, but I find that's a bad habit, a bad way to be thinking about it. It's always minus 9.8 because it's always acting against, the gravity is always acting down. So rather than thinking about it in terms of acting with or acting against, we should always be thinking about it as gravity's acting down, and it's the down that makes the minus, not the for or against, you know. You notice that even though my sign was different, I still got the right number value, just with a different sign. But it's useful to have the minus here because it indicates that the acceleration is acting downwards. So there's nothing wrong with the way you're thinking about it, and a lot of books, or not a lot of books, but a lot of classes would think about it like this. But I find it's better to think about it the way I was thinking about it, because when the questions become more complicated, sometimes it's difficult to know if you should use the plus or the minus in your situation, because you're like, oh, is it with it or is it against it, but it's going up, but it's coming, you know. The less thinking, the better. Yeah. Okay. How can we get the V here? Yeah. V equals U plus a T. And what is this then? That's going to be about minus 20? 22? Exact? Okay. Meters per second. Happy with that?
Yeah.
Yeah, good? Okay. Right, so here's Mary, and she drops the ball, and roughly speaking, you notice that the ball is getting faster as it falls, obviously. That's what things happen, that's what happens to things that fall. So at the very beginning, the ball's at rest. Then 1 second later, it's going at 10 meters per second. Then it's going at 20. Then it's going at 30. Then another second later it's going at 40. Then another second later it's going at 50. So each second it's getting faster by 10. So it's speeding up. It's accelerating. So notice that when a ball, why did I say bald? When a ball is dropped from rest, it will increase its speed by about 10 meters per second each second. That means the acceleration is about 10 meters per second squared. So to be more precise, the acceleration due to gravity on the surface of the Earth. We use the letter G to represent this. And for this course, the acceleration due to gravity has a value of 9.81. Yeah. This is the value of acceleration when something is fallen to Earth. For example, when you drop a ball. So it's enough to write down the first sentence, I think. The first sentence is enough. But Jerry already knew this. Didn't you, Jerry?
No, I can't.
You guessed?
No, I knew the exam we always use that.
Yeah, 9.81.
81.
Yes. Yeah?
Yeah.
So that's about 10, yeah?
The last question A, right, is negative 9.8. Isn't it deceleration?
See, this is, I think, what she's thinking about too,
Yeah,
isn't it?
I'm still thinking.
Think about it like this. Imagine you're here and you start walking to the left, so your velocity is -1 meter per second, and then you start running to the left with your speed changing from -1 to -11, for example. So the A here is -10 meters per second squared. So yeah, it's a minus, but you're not getting slower, you're getting faster. So yeah, I know this is one of those things with English, you know, deceleration, the D means minus, but that doesn't necessarily mean slowing down, because his speed is 1 and his speed becomes 11, but that's even with an A that's negative. So to me, I feel the best way to think about the plus and the minus is that it tells us the direction, rather than if it's helping to speed up or to slow down, because you can have cases where it's a minus but it's actually getting faster. So this is the way I think about it for the gravity one. Okay, so now we have a longer one to do. There's a lot of English here, so what I'd like you to do is just to draw and write the information down. Try to understand what the story is, and then we'll do each part together. So do your best at writing the information down, getting the information from the question. So if you can draw a picture of what's happening. Okay, has everybody drawn a picture of the story? Can I start it? It doesn't need to be a work of art. Your picture. Or are you writing it down? Okay. You drew a picture, KJ? Let's see. Oh, so small, I can barely see. Did you draw a picture of this? Let's see. Interesting. Can I see? Yes, okay. And for you, got a picture? Let's see. Okay. I think people have the right idea here. Let's have a look. Okay. So, let's just draw the ground first. Oh, no, that's silly, of course, because it's ground, it should be green. There now. All clear. No. Right, so we got the picture here. So, ball starts here. What height is this, did we say? 1 meter? So that's 1 meter. Then it goes up and comes back down. And it hits the ground. And I think I gave you the speed here, did I? 15. Oh, 50. Oh, she throws it hard, so 50 meters per second. Okay. And my first question is, what is the maximum height of the ball? So that is, I want to know this. Now, just to make this a little bit clearer, before we do anything, I need to draw in my axis. So here, this is the origin. This is where the ball starts. Okay. So, let's go to here. U, V, A, T, S. Well, I know the U is 50. That's fine. And I actually know what the V is. What's the V? Yeah, why 0? Stops and falls down. And I also know the A. It's minus 9.81. I don't know the T. The S is what I want. So what formula can I use here? If I'm looking for the S, let me see. V squared, is it? Yeah. So I can say V squared equals U squared plus 2A. What's that? 9.18. 19.62, is it? What's 9.8 times 2? 9.81 times 2. Is it 19.62? Is that a yes? Okay. 19.62. V squared equals U squared plus 2A S. So the S is 2500 over 19.62. What is that, please? Can someone give me the number here? I don't have my calculator open. 19.62. 127.4 meters. Yeah? Yeah. 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 You're still not happy with this? Yeah. The negative is because the G is acting downwards. Yeah. And which way does gravity act? Down. So the G is a minus. It's always a minus because it always acts down. Which previous one? Would the ball drop from the building? Basically, yeah, no questions. If you don't make the G minus, then what you're saying, which is fine, because it's only a sign convention, but what you're saying is upwards is negative then. Yeah, but I don't like saying upwards is negative. You see, I prefer saying up is always positive and down is always negative. So when the ball is dropped from a building, I like to say that the A is negative and the U is negative. The A is negative because it's still going down, but the U is positive because the ball is going up initially. See, the U is a 50 positive because at the beginning it's going up. No, it does not. For me, A is always minus 9.81. It's everything else where I have to think carefully about what signs to use. Yeah. Okay, this isn't quite finished. What is the final answer? It's not 127.4. You should plus 1, yeah. So the answer is H equals 128.4 meters because this S was for this. From here to here was the S. Is that okay so far? Yeah? So we go to the next part. The next part is how long until the ball hits the ground? Apologies, I haven't remembered everyone's name for certain. Monica, right? Yes, okay. So Monica, I'll have you give me the UVATS for the next part, part B. How long until the ball hits the ground? So what U should we use here? No. The U, yeah. So, sorry, I should draw it in. Yeah, the ball going from here, how long until it hits the ground? So, you were perhaps thinking from here, was it? Yeah, from here. Good, 50. The V... yeah, we don't know. It wasn't 0 when it hit the ground. It just became 0 after it hit the ground. So, we actually don't know this. Okay, the A... okay, good. The T... we don't know. That's what we want. And the S? Yeah. Oh, we have a few answers. Okay, let's write down our possible answers. So, are you saying 128.4? Okay, that's your answer. You had a different answer, Bruce? Oh, you said the same? Okay. Anyone else? No, we're starting from here, Jerry. From here to here.
We always get that in the high point.
Yeah, but I never got the time to get to the highest point. So if you got the time, now listen carefully, if you got the time to go from here to here, you would need to add it to the time to go from here to here. Because I want the total time. We never got the time in the first part. Okay, any other answers? This is it? No, it's not. Huh? No, you're wrong. Not 128 plus 127. Any other answers? You have an answer? What should I use for S? No.
My method is divided in two parts.
I hate this method because it's so long and so not necessary. But every year there's always one student that says, but teacher, why not do it in two parts? But there's a better way. I could do it in one part. Come on, somebody tell me what's the S here. Oh, you'll be so sad when you see it. I'm going to write down the answer and you're going to say, oh, of course.
The 2 points.
No, stop talking about 2 parts.
No, I mean 2 points. That's 2 points.
What 2 points?
The ball starts at this is the point. Example,
no, the start and the end is not the same place. Not.
They are the same speed.
Here and here? No. Here and here? Yes.
Yes.
But not here and here.
Yes, because the 8%.
The time, I don't know. Anyways, I'll give you the answer. The S is, now somebody was really close, -1. Think about it. Of course.
Oh, because it's dropping down.
Don't hate me. Hate the physics. The S is -1 because S is displacement and it is 1 meter below where it started. So the advantage, Jerry, is that I can do this in one part using this instead of 2 parts. Yeah. So if I'm looking for the T, I should go with S equals U T plus a half 4.905 T squared. So in other words, I get 4.905 T squared minus 52 minus 1 equals 0. Have you seen this problem before in another subject you study? What type of problem is this?
2 times.
Yeah.
2
Yeah, what's this called? Do you remember? Quadratic, very good, yeah. So, we have some ways to solve this. Can we factorize this? No, it's too messy to factorize. Could we use complete the square? Yeah, we could. It's messy, we could. There is another way to do it, which we'll learn about how to do in math class. But for today, in physics class, I'll show you how to do this on your calculator. Because your calculator can do this for you. Okay? How many people actually have the Casio calculator? Just one? Just Monica? Texas TI. Dude down the back? Calculator? No.
570. I tried to open that with my laptop, the Casio one. It doesn't work.
Program? You tried to open the Casio program? The calculator, it doesn't open? What type of computer do you have?
Mac.
Well that's the reason.
Yeah.
It was a Windows file. Okay. Anyways, for the one person who has the right calculator, Casio 991, yeah, you can solve this on the calculator by typing mode 53. So mode 53. You have that, and then you type in the 3 numbers. 4.905 minus 50 minus 1. 10.2. Don't take the minus answer. T equals 10.2 seconds. Now the people who don't have this calculator, which is everybody else, you will have to use, for the moment, completing the square to solve this. There is another way to solve it. If you know how to do it from high school, you can, using the formula. But if you just want to use for today, you can just use the Monica's calculator.
Our calculator works on this.
No, I'm sure it does, but can it do it as quickly as this?
Yeah.
This calculator can do that?
Yeah.
For real?
Yeah.
What do you press together? What mode?
What equation, degrees to, just type in a...
Okay, I've underestimated this calculator then. So if you have this one, which one is that? Casio?
570.
You press mode.
And then equation.
Which number is that?
1.
Mode 1.
Mm-hmm.
Okay, if you have some other calculator, you could try mode 1. Gives you the same thing. Okay, fair enough. What about TI? No.
It's a basic one.
Oh, it's a basic one, okay. Right, let's continue. How far does the ball travel? Okay, so what's the answer here for part, that was part B, and this one here was part A. Okay, part C, how far does the ball travel? That is 127.4 plus, yeah, or I'll say it as 127.4 plus 1. So that's, thank you, 255.8, yeah, sorry. Okay, how fast is the ball going when it hits the ground? So B equals U plus AT. B equals 50 minus 9.81 times 10.2. Okay, let's see this one here. 50 minus 9.81 times 10.2. So its velocity is minus 50.06. Which means its speed is 50.062. That's how fast it's going, its speed. Okay, and finally, what is the average speed of the ball? Okay, so how can I get the average speed here? And you need to think about your triangle. Total, yeah? Yeah? Yeah, that's it. So on average, the speed of the ball is 25.08. Yeah.
Can I ask the previous one, the part A, why the displacement is not negative 127.4 and the part B is S equals to B?
Yeah, so if you look here, let me help you out here. Yes. Hey, you need to talk to them?
Yes.
Okay. 1 sec, I was just in the middle of answering his question then. So here, if you can picture the number line like this here is minus and this here is plus, and the ball starts here and it goes up and comes back down. Oh sorry, that's plus, I said that backwards, that's minus. It starts here, goes up, down and finishes here, is 1 meter below where it starts. So the S is a minus 1.
Okay.
Is okay? Alright, okay. Yeah, go ahead.
Hello engineers. My first time seeing you as a group. My tutor group last year were the engineers and they were just the best group, weren't they?
Until this group.
Until you came along. I must get some advice from them for you. I should contact them. Your insight onto Stephen. You can tell that Stephen is such a genius that he has invented a way to write on the board without standing up.
I'm also lazy too.
What kind of genius? So, I'm here to talk to you about what's happening on Saturday. What's happening on Saturday? Bushcraft. Have any of you ever done this before? No. If you were in a forest after falling from a plane alone, could you survive?
Yeah, of course.
Of course. No. So if you come to the workshop on Saturday, you learn how to build shelter, find food, all of those things that you need for survival. So it's great fun. And it's a great experience for you to be in the woods in Ireland. I'm sure none of you have done that before. It's early in the year, so maybe you haven't got established friends and stuff, but it's a great idea to come along so you'll meet people, you'll get to know people, because all the IS students
IST students will be added. IFI Business, Engineering, Science, PMP, English students all coming together. Okay? And ordinarily it's very expensive, so we're paying most of the price and you just pay €10. Okay? So, did you get the invitation I sent you by email?
Yeah.
Did you register? You need to do that because there's limited places. So if you don't register soon, you won't be able to go. So if you want to register today and then come to my office and bring the €10. We'll organise transport from the college to there for you. Okay? So we'll meet at the college and get to Phoenix Park. So don't worry about anything, just come along and have great fun. Yeah? Did you know that Stephen is an expert in bushcraft? Yeah. He once survived in the forest on a mountain 2 months.
Just me and my maths.
Calculating everything.
That's it.
Okay, so you'll register. Has anyone any questions?
Do we take something?
Not at all. Huh? Clothes, yeah. No, I'll send you an email with what to get. Maybe some Wellington boots, waterproof clothes are good. If you have waterproof. You can get them all in pennies for nothing. Okay, so it's no big expense. You coming, Jerry?
I won't.
Super. Register today. Okay? Brilliant. Thanks.
Thanks, Emer. See you. It's the students last year had lots of fun. It's really good to go to. They had lots of fun. So if you can, you should try to go on Saturday then. Okay. All right. So are you happy with that minus answer? It's okay for you? Yeah. Okay. Any other questions about this example? Now I should say this is a great example because it kind of gives you a good feeling for what an exam question would be like. So this would be very typical of an exam question, and a very common well, it's not a mistake, Jerry, but a very common thing that annoys me in the exam is when students break this into 2 problems. I just feel like they make their life harder. Yeah, but I mean it's fine. You still get full marks. It's no problem. A couple of other small mistakes would be with the -1. People accidentally use this instead. You know, it's good to do this now because if I want to make sure that you're thinking about this the right way. Okay. Now, what we'll do, I have questions here. I was hoping to get 2 lessons done today, but with all the announcements and everything going on, I don't think there's really time to have a look at the second lesson. So I'll just give you the questions for this lesson and you can start them now. I also know that you didn't get a break this morning, so instead of finishing at 10:50, we'll finish at 10:40 then, okay? So if we just try these together for 10 minutes. Again, 7 questions, all using UVATS, okay? And when's our last physics class of the week? Is it on a Friday or do we? When's the last physics? Friday at what time? It's a Friday anyways. During the Friday class we might take some time just to have a look at any problems you had from the homework so far, spend some time doing them together, okay? So it might be a good idea before Friday's class to maybe write down the questions you would like to do together then, okay? So let's... This one? Fast lesson? Huh? On Friday? Oh, it's 9 o'clock? Oh, okay. This one. Yeah.
So we don't have an assessment for this week.
No, I started next week. Well, I don't think with Connell. It's too early to start it in week 1 because there's not enough done. I'd like to start it in week 2 then. I think Connell might be the same because I told him I won't start till next week. So he might be thinking, well, if Stephen won't start till next week, then I won't start till next week. There you go.